Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of one-variable equations. This is standard 8.8C in the great state of Texas, and we are using item number 8 off the 2018 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we've got Julie starting with some gum and giving some gum away. Conrad is starting with more gum and giving twice as much away. And we don't have an equation to solve here. We at least see that our pieces, that's going to be our variable, giving away x pieces. So how many pieces of gum did Julie give away if they had the same number? All right, so that lets me know it's going to be an equation because we're going to equal. So if they had the same number of pieces of gum left, so this lets me know that Julie is going to end up with the same number as Conrad. So J equals C. So that's going to be my basic equation. Now let's start filling this in. What do I know about Julie? Julie started with 20 pieces of gum. All right, so that's going to be my constant. Let's just start with a 20. Gave away X pieces. So we're not adding X. We're subtracting X. Negative x's are annoying. We're going to try to make that positive if we can. So she had 20, gave away x. Conrad started with his constant is 35 and gave away twice. All right, there's a vocabulary word we've been learning since kindergarten. Twice means 2 times. 2 times what? 2 times as many pieces as Julie did. Well, how many did Julie give away? We don't know. She gave away x, but you know what? That gets us another variable. So Conrad is going to give away twice 2x. So once we can get to this point, this is an equation we can solve. But 20 minus x is how much Julie started with and gave away. 35 minus 2x, 2 times as much as Julie did, which is the unknown x. That's Conrad. All right, so we want to get the x's onto one side, and if possible, we want to make them positive because, like I said, it's kind of annoying when you have a negative x at the end. You have to multiply by -1 to make it a positive. So watch what I'm going to do here. I'm going to add 2x to both sides. If I add 2x to both sides, well, negative x minus 2x, that's going to cancel itself out, right? That's just going to zero out. But we'll leave 35 here. Negative x plus 2x. Now, if that's not apparent to you, you can easily just flip that, right? You can use the commutative property. And you could do 2x minus x. Well, if I 2x minus x, that's just going to leave me with x. So even though it was annoying, I'm just left with x. So when I get the constants on one side, I'm not even going to necessarily need to divide by anything. I have 20 plus x, because negative x plus 2x is just positive x, equals 35. So now let's get this 20 out of here. And let's do that on the other side to keep a balanced equation so that x is isolated. So it looks like x equals 35 minus, that is not a 0, that is going to be a 15. 35 minus 20 is 15. So x equals 15. Let's double check. My Julie had 20 minus x, which is 20 minus 15. That's what I think x equals. Conrad had 35 minus 2x, or 2 times 15, so that's going to be 5. 2 times 15 is 30, so is 35 minus 30 equal to 5? Yes, it is, because 5 equals 5. So that's how you double check. You need to get a true statement when you plug the variable back in. If you do, you know you found the correct value of x, which is 15. So my answer here is going to be H.